Hello, my name is Amir, and I'm going to present you a demo of InterSystems IRIS with Kafka. So here is what we are going to see. So we're going to see InterSystems IRIS consuming Kafka topic, and we are going to be populating this Kafka topic with several different events with different schemas. So it's not like the typical topic that has a single schema. We will be seeing different events, all with different AVRO schemas. So we're using AVRO here also to create these messages. We have created as a bank simulator. It's not a real thing, but it is capable of simulating the creation of new customers in the bank and the opening of their checking accounts, the updates to their demographics, transactions like transfers, loan contracts when a customer asks the bank a loan, and payments to these loans that happens every month. We will be pulling these events from this topic using a normal Kafka consumer API. And to do that, we are going to use InterSystems IRIS packs or production extensions. This allows us to code, to use Java to use the consumer API to pull the messages from the Kafka topic, but into the InterSystems IRIS framework. So we are going to be looking at InterSystems productions and how we deal with integrations to legacy systems or modern systems like Kafka in this demo. Number two is about how we hold the data inside InterSystems IRIS. So we are storing the original data that we pulled from this Kafka topic into InterSystems IRIS. This storing the original data is important because it's forensics, right? It supports investigations of why a transaction or an aggregation at a cube or the results, an aggregation in a report, it has those values. So if we do the tracing, if we follow the data, we will be able to explain why we're seeing what we are seeing on these dashboards. That's also known as data lineage. When you go from the aggregation and you look at the data, and then you realize that the data was transformed and what was the original data, we will be able to give you this explanation. So in summary, we are storing the data, the original data we pulled from Kafka as evidence to support this. And where we are storing this? On tables. InterSystems IRIS is capable of holding these tables, and they can be sharded, they can be as big as you need them. In this case, we're not using sharding because I will be presenting this demo on my PC. You will see that you'll be able to do the same to run this demo on your PC as well. But the data will be stored on these tables, and these tables will be created automatically based on the schema that is on the schema registry, on the Kafka schema registry. So we'll be pulling the schemas from the schema registry and using that to create the tables. So that's what we're going to see. And we're going to have a look at those models and how we can use SQL to query the data, and how we define these tables using classes, because InterSystems IRIS is a multi-model database. So I'm going to give you the chance to look at these classes and run some queries. So finally, we need to transform. So the original data, they are just events. We need to compact these messages, these events, or collapse them into a canonical model, into a database model that is good for querying and for reporting. So we're going to show how we do that, and sometimes we need to join data from other tables, like I'm getting this loan contract. This belongs to a customer, and I need to link to the checking account where the money goes. So we are going to show how we do that. This is also known as enriching the event with additional events. And finally, we are going to show how we can apply a lookup or transform a field in the message to something else following a lookup table, a transformation that maps a code to another code or to a description, for instance, or make sure we are using the standard reference table for some domain, like United States states, but it could also be a reference table for legal entities, a reference table for bank products, and so on. So on number 4, we are going to have a very quick discussion about losing messages, the Kafka risk. Kafka, if not used properly, you have the risk of losing messages or getting duplicated messages. And we are solving this problem here we are taking care of this problem here on InterSystems IRIS. A really quick discussion about security. And then we are going to try to break something, right? Nothing is perfect. So we're going to break something and see how InterSystems IRIS helps us to stop the production line, send an alert, get people involved, so we can look at the problem real quick, fix it, and then make the production line, restart the production line, and that's we are trying to protect the canonical model, right? We're trying to ship only properly finished data. So we are making sure no defects arrive at the canonical model. And finally, we are going to explore the data on the canonical model. We are going to make some queries, access the data using REST services, and even a BI, business intelligence cube. So let's get started. So this demo is on GitHub. You can deploy it yourself on your PC. You just need to clone that repo, go to that folder, and run Docker Compose up. I'm using Docker because there are several moving parts here, like the Kafka broker, InterSystems IRIS. So we are starting all these services on your PC. So when we start the service, we'll be able to open this URL that you see here, and we'll be seeing this. And this explains the entire demo. So here we have the bank simulator that is simulating a checking account, core banking system, and we will just hit a button here that will start this simulation, and we will start receiving messages. Well, the simulator will start sending these messages to the Kafka broker right here, and we will be pulling those messages using a connector into Iris, and we're going to store those messages here, those events here, as the original data. We're going to be using the schema registry to pull the schemas and generate those tables. That happens before, okay, and before the events arrive. And then we are going to start sending these events to a process that will normalize this into the canonical model, applying transformations and the reference data. If something goes wrong, we are going to send an alert to someone, to a group of people, and they will be able to look at their inbox and see a workflow ticket waiting for them, right? And then we're going to explore the data here using SQL, cubes in business intelligence, and REST. Other options are also Spark, like if you want to build a machine learning model on this data, integrated ML. It's a feature of IRIS that automates most of the work on creating and running a machine learning model on your SQL data. or you can even push the result of this canonical model out to another Kafka topic, right? But we're just going to be showing these three uh, points here. So let's start with the simulator and sending some messages. Okay, so let's go to the demo. So here I am on my terminal, and I don't have the demo started just yet. I waited. I will just say here docker compose up, and this is going to start the demo. That's what you would do on your PC if you wanted to run this demo. While this is starting, we can take a look at that folder here. I have Visual Studio Code opened, and as you can see, this is a Docker Compose file I'm using, and we have Iris here as a container. We have this node here and this for the simulator, the bank simulator. This one here is also belongs to the bank simulator. And then we have Zookeeper, which is a requirement for the Kafka broker. The Kafka broker is here, the schema registry, right? So all these services are being started together right now as we speak. So the entire source code is also here. You can see how we built it. One of the things that I did, here is the InterSystems IRIS image, right? And this is the PEX adapter here that InterSystems IRIS is going to be using to pull messages out of Kafka. So it is a Maven project, and this is the source code. So I have to create a Java class that inherits from this InterSystems class inbound adapter. And if you're familiarized with Kafka, you're going to notice that I'm creating a typical consumer, Kafka consumer here with some configurations. I'm subscribing to a topic, and then on this onTask method here that is called by Iris over and over again, we're just pulling that topic, pulling a batch of records, and then pushing those records into InterSystems IRIS. Okay, so let's see how that is. Okay, looks like it's done starting, right? So I'm going to open Firefox, and I'm going to refresh this URL here, and this is the landing page of the demo. The password is on GitHub, so I'm going to type it here, and that is the land page we were discussing in the presentation. About GitHub, again, this is where the demo is. It's on GitHub. Most of the things we are discussing here is very well documented there. How to run the demo, the git clone command, the Docker Compose up, screenshots, everything that we're going to see right now is very well documented there for you. And I will be coming back here to copy and paste some of these queries, for instance, so I will leave this open. And here we can click on this button, open all windows, and it is going to, this is the same password here, and it's going to be opening up all these tabs that maybe I should just, I think that got in the way. Oh, there you go. I'll just close them because I want all of them open, and I had to type that password again. So open all windows. So let's just wait as these tabs are open, because we're going to be showing real quick all these pages. So there you go. We are almost done. Yeah. So first of all, this is the cluster we have. And if you look here at the consumers, I already have Iris uh, as a consumer here. And it is subscribed to this core banking system events topic on the Kafka broker. And no messages have been ever sent to this broker. It's empty. Okay. On the next window, I have the simulator, and I'll just click here on run, and it's going to start sending messages. So it's not too fast. It's about 1,500-600 messages per second, but that's okay because we are going to leave this running. It's a simulation, okay? But if we go back to the control center here now, you can see that we have messages, and the current offset is Iris. Iris is always catching up. Sometimes it lags behind, and sometimes it just catches up. It's almost synchronized. Iris is consuming all the messages that we are publishing into Kafka. So here is the production. So this is where we configure all these things. For instance, this is the service that is pulling messages out of Kafka, so we have to configure the broker here. So this is a service that we built using production extensions. So it's just calling that Java class that I showed, but that Java class is nicely exposed inside Iris. You can configure that Java class with a URL for the broker, the topic, the group ID, and all these typical configurations that anyone familiar with Kafka recognizes, right? And this is just pulling those messages, and they are being stored in the database, okay? So let me go back to that PPT so we can see what else I need to show you. So we took a look at real quick about on that Java code and the simulator. It's now running, sending events. So now we are going to look at where those events are being stored, in which tables, and access that using SQL. So let's take a look at some of these events first. So here's a simulator, and it's sending those messages to the Kafka broker, and InterSystems IRIS is using that Java class to pull the messages and store on tables. And the events are these. So new customer, when new customer is created on the bank, the customer changed its address or phone number, so we have a demographics AVRO event. A loan contract, the customer ask the bank for a loan, and transfer money among customers, but also when you get a loan, you get money from the bank, and this is also a transfer. So these are the 4 types of events that we are getting from that simulator. And you will see that we will have tables that will have the same name inside InterSystems AVRO, InterSystems IRIS. This is an example of an AVRO schema. Okay, in this case, for the new customer AVRO event. So here is the namespace, and here is the name of the event, new customer AVRO event, and we have, for instance, what's the name of the customer, its account number, initial amount. So this customer just opened a bank account with us. What is the initial amount? Where does he lives, or she or he lives, and so on and so on. And here is an example of not an AVRO message, because this is JSON, not AVRO, but it's a JSON representation of an AVRO message, so that you can just see what we're talking about. It's random data, but the customers are The simulator takes care of really creating customers and simulating transactions among these customers. So we'll be able to look at data that is meaningful. All right, let's look at this. So again, this is pulling messages from Kafka. This is the schema registry service. This is the service that is talking to the schema registry and making sure we have inside IRIS all the tables needed to hold messages, to hold the data coming from Kafka. So we coded this service using InterSystems IRIS, calling the schema registry using REST. Okay, so it's really really easy. So what I want to do is show you the tables. So here you can see the first one. This is for demographics AVRO event. I can execute a query here, and there you go. You can see that those messages are done processing. I have the customer ID here, the event ID, its name, city. You see how we are making the city here, like the address underscore city, address underscore phone. This is something interesting about our multi-model capabilities. If you look at the schema, address is it's an object, and it has 3 fields: state, city, and phone. So here, when we are looking at this as a table, we see address underscore city, address underscore phone, address underscore state. If you look at this using the Visual Studio Code and you look at the code that is generated inside IRIS, core banking, demographics, AVRO event, you're going to see this. This is a class, and you're going to see that we have a customer ID, the event date, event ID, the name, and the address. The address is here, and it is an object. And if I jump there, I'm sorry, there you go. I have city, phone, and state. So we have classes that represent this data inside InterSystems IRIS. But when you're looking at this using SQL, that is how you see it. If you're going also to notice that the demographics AVRO event inherits from an all objects class, and so we have inheritance here, and that is something that's very cool. So let's look at another one just to. So this is a loan contract AVRO event. So again, it talks about a customer, but it has now a contract ID, the amount that I am lending as a bank, right, to which customer. As you can see, we have these other columns here that are control columns. So when did I get this message? Is it processed? Is it pushed into the canonical model already or not? Did I have a problem with that? What is the session? We're going to see what that means shortly. But here is the all objects table. So the all objects table, it's like you have to think about inheritance here. So if you have a parent class and those 4 events are children of this parent class, you're looking at all rows from all these 4 tables when you're looking at this table here. So this is very, very cool, right? If I some of these rows new customers, some of these rows are loan contracts, and so on and so on. And we have a way to differentiate this, but we can use polymorphism at the database level, and we're doing that here, but this is another discussion. Another way of fetching the data is using REST. So Now this is the schema registry. Let me just see which window I'm going to use here now. There. So this is a REST call that failed because I need to refresh it. So I'm just asking for that same event, core banking com InterSystems new custom AVRO events, and I'm asking for event number 2. And there you go. So if you have an application that needs to fetch the data using REST, it's that easy. You can really write these REST services directly in Iris, and we can scale this horizontally for you. Those are data-driven services that are delivering data. In this case, it's original data that was coming from Kafka, but it will soon come back here and show that we can do the same for the canonical model. Okay, so let's go back to the PPT and see what's next. So what's next is that how are we transforming these original data into the canonical model, right? So let's just jump right in and look at that. So the simulator is there, running, pumping messages in. So here we are pulling the messages from Kafka, but this service right here is pulling those messages from inside Iris, the original events that we have stored already, and pushing those original events to this process that is right here. And this is the process that is orchestrating this work of transforming, taking the original event and applying it to the canonical model, and applying transformations and lookups and making sure everything works okay. If it doesn't, it will send an alert to someone and will create a workflow ticket to an application specialist, to a data steward, to look at the problem. It will stop the processing of events, so the data steward can look at this and fix the problem. We are going to look at this later. This process is right here. So we will try to normalize the data. If there is a problem, this is the workflow that will support the solution of this problem. It sends an alert to the data steward, create a workflow ticket, verify the answer from the data steward. Should I retry this operation? Should I discard it? So this is the process that is orchestrating this work. And this process is using a transformation like this. This is a transfer, right? This is one of our most complex events. And here in the left, we have the original AVRO event. And in the right, you have the canonical object for that. So if you click here, for instance, you can see that the amount of the transfer is coming from the amount field. You can see that the movement date is coming from the event date, the transfer ID, and here is the other account that we are either sending money to or receiving money from. And here we are using a function, checking account, with the other account number to instantiate that object here. And here we have more, a little bit more coming in, right? So let's open this up. So first of all, we have this, and this is kind of the same we're doing here, but for the customer account. So this time we are instantiating the object of the customer account, and here we are just applying the amounts. What does that mean? We are adding the amount to the customer balance. So that amount can be positive or negative. So it will either be sending money or receiving money, right? So we just updated the customer account here. Finally, we need to store the rolling balance, right? So the rolling balance is just what? That's the property that I'm saving at, the rolling balance. That's right here. And what am I storing there? The current account balance that I just updated. So that is my current rolling balance, and that gets stored in the movement. So every movement will provide me with the rolling balance of that customer at that date, at that specific moment in time. Finally, we have the movement type, right? And if this is a loan contract, if this transfer is about a loan, am I paying a loan? Am I paying a loan monthly? Is that the transaction I use to pay that that bill, or is the bank send me the first chunk of money for that loan? So this is also a transfer. So we are making sure we have a switch here that is looking at the type of transfer. Is this a loan payment? So I need to instantiate the loan contract. Is this a loan transfer from the bank to the customer, right? And so on and so on. So we're doing a lot of stuff here to populate the canonical model and enrich that event with data from other sources, right? Another simpler transformation that I want you to look at is the demographics AVRO event. So this one here, remember the address? It has these three fields, and here we have the three fields mapped: the state, the city, and the phone number. The phone number is not in the address in the canonical model, is outside the address. Makes sense, right? But look at the state. State is, we are just copying the state code to a state property here. And we are using the state property again, but this time we are applying a lookup. So if you click here, you're going to see several functions that you can apply, and you can create custom functions yourself. In this case, it's a lookup table, and you can pick a lookup table. I have just one here that translates states, United States codes to descriptions, and I'm saying what is the value from the original event that I want to use to on that lookup. And this lookup is just right here. So here is the original code, and here is the description. So we are making sure that our canonical model is using the proper reference tables. Again, those could be legal entities, those could be product, standard products, bank products, United States, and so on. Okay, so that is the process and the transformation. And this process has been working a lot. Let me see if I'm not... yeah, we talked about all of that. So let's see what's happening, right? Here is the message viewer. So these are messages that are flowing, flowing into Iris, and this represents work we are doing. If I click here and click on search, you see that I am always getting new messages. And if I click on any one of those, I can click here and see its contents. So in this case here, this is a transfer, and I can look at its trace. So what is this? Let's look at this closely. So this represents the transformation. That's the process we were looking at. right here. If you go back to that production, you see this core banking normalization service, schema normalization process, right? And then the trace operation. Here we have the core banking normalization service sending a message. This is the original message. In this case, a transfer. It's saying here transfer AVRO event. The process is applying that transformation we looked at with these lookup messages, and we are getting, this is the final result. So it's complex here. This is like a graph view of the canonical model, right? The other account object that we instantiated, the customer account, the rolling balance is right here, right? It's matching, it's not matching the balance, right? Because probably there are more transactions that happened after this one on the same account, so it's not matching anymore, which is great. It allows us to see the rolling balance in action, right? So at this specific date in time, that was your balance, right? In this case, this has to do with a loan contract, so we got it instantiated here. How do we know that? Well, because of the transfer type, this is a loan payment in type of transfer, and it has a reference. And that reference number here is the loan, it's the contract ID. And that's what we used in the transformation to instantiate the contract. So that's all the work. We did a lot of work on this transformation here, right? And this got stored in the canonical model, right? So now let me go back to the PPT so we can make sure we're not missing anything. Well, before going on talking about losing messages or duplicating messages, let's take a look at the canonical model, right? So here is their canonical tables. So let's look at the customers. So we have a bunch of customers now, right? Those tables, they were empty. And here again, address underscore city, address underscore state. Look at the address underscore state description. It's populated with the values from that lookup. This is looking great, right? And we have what more? Loan contracts. All the contracts. And that's the loan amount right there. Amount paid so far. This is being updated as we speak, so we can keep track of who is paying the contracts. What else do we have here? The movements, right? So these are the movements. So I have some queries that we can run, but I will refrain from running them right now. I'll leave this to the end. Now let's go back to the PPT and talk about losing messages. So Kafka allows you to, it comes by default committing the messages asynchronously. As you are pulling messages out of Kafka, it automatically commits this to the broker. So the broker knows in which message you got last. But sometimes things may not work so well, right? Your software may crash, a transaction may not work, you may have a problem, and then you want to restart your process and pull your messages from Kafka. But if Kafka was committing those messages like automatically for you, and you restarted your process, you may end up not getting that last message that you had in your hands when your program crashed. So we turn that off. We turn this auto commit off, and we are committing to Kafka when we are ready, when we know that. I can show this really quickly here to you guys. This is the Java code. So here is the commit sync. So we are synchronously committing after we pushed all the messages here into Iris. Okay, so this block here is where when we are taking each message from that batch of records we pulled from Kafka, and after we are done pushing all these messages into InterSystems IRIS, we do a synchronous commit. So that solves the problem of losing messages, but it creates a different problem, right? Now we may get some duplicated messages. So we have solved for that as well. As we are pushing messages into Iris, we are also telling Iris what is the partition we are reading from, what's the offset, and then where the data has to be saved inside InterSystems IRIS, and the data, right? And we're pushing all of this into InterSystems IRIS. So if InterSystems IRIS realize that we got that offset already, we just skip it. Okay, so we are not reprocessing those events. We have those already. We just skip it, and it's that simple. Okay, so we have this taken care here. So what about security? We are storing all this data inside InterSystems IRIS. So InterSystems IRIS needs to be safe, and we have all that is required, role-based authentication, the tables there that you saw, all the typical SQL stuff, like role-based authentication, column level security, row level security. We can integrate to your LDAP, your Active Directory, or your Kerberos for authentication and authorization, or else too as well for your REST services. We can encrypt the data inside IRIS using advanced encryption systems with a strong symmetric key. We encrypt everything: tables, indices, log files, the journals, we call them journals, everything. We can encrypt the data in transit. For instance, we can replicate your data to another node for high availability, and this conversation between the two nodes is protected by encryption. So everything is protected. Again, this replication provides high availability. We can also replicate your data to another data center for disaster recovery. And we can also protect your REST APIs, because InterSystems IRIS comes with an API manager. So you can apply security, throttling, metering, all these concepts of an API manager. Okay, so let's break something, right? Let's break something. This is all working so well. Let's break it. And here is how we're going to do it. I'm going to first, let's see if the simulator is still running. Oh, it stopped sending messages to Kafka, but I bet we are still processing some of them. So let's see here. Yes, great. It's still processing. So let's be quick about this. Let's kill a state here, like I don't know, Alaska. I'll just kill it and save. Okay, so this state doesn't exist anymore. Just to be sure, let's break something else. Like let's take Alaska and Maine. I have to take AK and ME. So If something breaks, we are going to see here on this. There you go. This is the inbox. I just got an alert that something broke, and I got a ticket, a workflow ticket, and the following problem occurred. That's a session number. This is the state description that is gone. It's required and it's not there. So this problem is assigned to no one. The role is the application specialist, or it could be the data steward. I picked a bad name here. I think the data steward would be much better. And here's the age of the problem. It's 10 seconds ago. If you refresh the screen, you're going to see that's a little bit older. So I will just accept this. And I can retry the process or discard that message. Maybe it's so broken, that message. It's something that I can't fix, and it makes sense discard it. The options that appear here are dictated by this process. Okay, so this is a demo, so it's very simple. This part here of the UI could be a form with all the fields of the messages, all the details you need to make a decision. But with this session ID here, we can do magic. We can come here to the message trace, and we can find any message here with a lot of criterias, and by its content, by the account number of the customer, by a date, by the contract ID. In this case, we have the session ID, so it's very straightforward. I just paste this here and I search, and this is the trace of that problem, and I can click and see that trace is now different from that one we looked previously. So this is the state here, Alaska, right, AK, and I got now this diamond here that is telling me some details about the object that I was trying to build, a trace saying that I got a normalization problem. This is the process generating the alert. That is the alert being sent. This could be sent by email, a text message, anything you need. Maybe it's calling to your ticketing system. And here is the workflow, that ticket that is waiting here for a response. So now I know what the problem is, and I'm a very smart data steward. I just realized I need to add, I'm sorry, wrong button, AK back here, right, Alaska. Hopefully I'll type this right. Apply. I think I will put main. Oh no, let's leave it. Just save this. And now that I fixed the problem, I can retry that message. I will just reset this search here because I want to show something else. Remember previously when I was clicking here and clicking on search, and I will have to click here again and again because there were many messages coming in. Now this is stopped. So the processing has stopped, because this is following, we don't want to keep pushing trash into the canonical model. We want only clean data there. So it is stopped, and it's much better this way. So now we can retry that, and we did. So if I come back here now and click search again, what's going to happen? It's gone. New messages are coming in. And we got another problem here. If we go back to that workflow and we refresh, that is another problem. And I'm going to accept that as well. Take that session ID, go to that message. Oh, just before fixing that second problem, please allow me to show you what happened to that trace that we were looking before. If I refresh this, please pay attention that this is the last event, the last action on this trace, action number 6. Now you can see the workflow response. and you can see how long did I take to solve the problem. This is things that I can query using SQL and report about it. So we can measure performance of like your mean recovery time, for instance. And you have a log about what the specialist decided. The data steward decided should he try, and we managed to transform that message, and now Alaska is appearing there. So this is evidence. This is forensics that shows what happened and how your data become what it is. So this is very important. And we store this for how long do you need it? For days, months, or even years. All right, so let's go back to that second problem, and I'll search for that session ID that I got, remember, from my workflow ticket, and I'll search for that. This is the session that is causing me problems, and this time this is main, right? We deleted 2 states from the lookup table, so let's put that back as well. Main. Hopefully I'm typing this right. I'm sorry if I'm not. I'm going to save and go back to the workflow, and let's retry. And off it goes. And if I look at that trace again about main, if I refresh that, you see that I got a similar trace. This time it worked, and the specialist asked to retry, and we got main there, right? So now let's reset this search that I have saved here, and it keeps going. I'm processing all the messages inside InterSystems IRIS. So we are getting close to the end. Now let's just take a final look at the canonical model. Okay, so here at the GitHub page, I have some queries for you guys. You can just, for instance, see how many messages have you processed. So if you come here to that SQL page and just paste that SQL query, you're going to see that I have 600,000 messages processed, and I have 145,000 pending. So this is a control table. Here, find customers that have many bank transactions, and find customers that have many bank transactions and loans. This is interesting. Let's look at this one. So this is ordering by the number of movements from the account that has the many movements to the less movements, right? So the bank, which has all zeros here on the account number, is the one that has most of the movements. We are asking to see, look at this arrow syntax. So this is a SQL extension to InterSystems IRIS. InterSystems IRIS has this as a SQL extension. So I'm asking to see from the checking account movement table, there is an account property, an account column that is a foreign key to the checking account table. And instead of joining with that table, I will just use the arrow syntax and say, I want the account number. Just traverse this. The same way you do with the dot syntax in objects. You can do that here with the arrow syntax in SQL and avoid complex joins, right? And I'm showing the account number and grouping and counting how many transactions under that account number. So if I update this, I'll probably see a different result. Yeah, most of them, this is random data, so it's kind of similar. Let's take this account number here, and I just want to get this customer balance. So I'll pick this one here. So here is the balance of this customer. That's the name of the customer right there. Its account number, his account number, his opening balance when he created the account. And we have several movements with dates here that are changing days, 14, 15, 16. He got a loan. That's the loan contract reference. And he is paying for the loan. So this is a negative amount. And you see the rolling balance being updated here. So the point of this query is to show you again the arrow syntax in action. I'm doing a query from a single table, the checking account movement, and I'm searching for all the movements which the account arrow syntax account number is that number. So I avoided a join here, but then I am using the account reference here again, and then look at this. Account, arrow syntax customer, arrow syntax full name. So I can keep going and jump to other objects in my database, to other tables, and keep fetching the data that I need, avoiding more complex joins. So this can make your life really easy when you are building your queries. Remember that REST service that we had here? We can also ask for data in the canonical model. So canonical customer, there you go. He lives in California, and that is his checking account number 2, right? It's balance, opening balance, so he has much less money now. So this is REST service, and again, this can be protected by our API manager. The last thing that I want to show you guys is that you can use InterSystems IRIS. This is our management portal. You can use InterSystems IRIS to really build cubes, and I have one built here for you already, a loan. And here at the left we have the loan contract table. Here again, the arrow syntax is helping us to navigate on the data structure without having to do complex joins. We are interested into the amount paid so far for that loan, so we dragged that from here to there, and the loan amount, I dragged it there too, and the contract date, I dragged it here as a dimension. If it's paid out or not, so this is an expression. If the amount paid is equal to the loan amount, it's paid. It's just a demo, right? And I'm translating that to paid out or active. I have a detailed listing that you're going to see what that means, and I will build this cube right now. So I will build everything. I'm just loading the cube with data. So we have about 50,000 loan contracts here on our small simulation. So I will just run analyzer now, and here we have our 50,000 contracts, and I could ask to see only, the contracts. What is the split, right? So I have 50,000 contracts that are active, 3,000 contracts that are paid out, right? And I could keep going, and okay, I want to see this by month, right? And maybe I want to know who paid these 3 contracts here. I can look at this and go to the data. So now I am seeing what is that aggregation made of. This is the real table, the original loan contract table, and we can jump from the cube, from the aggregation to the relational data. And then we can keep going and reach the original data and do the complete data lineage if necessary. You can look at this real quick with graphics here if you can, but this is a pivot table that you can save and just drop into a nice dashboard. So this comes out of the box with InterSystems IRIS and is being kept current with your transactional data in real time, which is something that we do out of the box as well. You can also use Tableau, you can also use Power BI and many other tools to query IRIS using SQL or MDX. All right, so that's it. This is the end of our demo. I know it's a lot. If you have any questions, just drop me an email. Everything is on GitHub. Thank you very much.